Good morning, students.
Remove the curtain of monitor. Curtain.
Means
But the
light is not.
light is better.
Okay. So good morning.
You should ask Yogesh to give the attendance. Did you inform him in a calendar?
No, sir.
Let me go after conversation. Let him call immediately because immediately absent mistakes.
What is this tensor in this batch? See the batch. So good morning, students. Okay. So can any one of you send me the message what we have taught or what we have discussed in the last class? Anyone? Can you send the message? Only words. What we have discussed in the last class. First. Shubhodaya. Okay, we started with functional groups. Very good. Right? We started with the functional groups. Okay. Now only functional groups, or before that we have discussed? Yes, very good. Then we have discussed about the line structure. Line structure. Then what else? Line structure. Then what else? Then we have discussed about the condensed structure. Writing the organic compound in different way. That is line structure, condensed structure, then Lewis structure. Right? So these are the different ways where we can represent an organic compound. Yes, even we have discussed about the dash structure. Yes, very good. Then we have discussed about the dash structure. Then any other concept which we have discussed in the last class? That one word I want, that is homologous series. We have discussed about homologous series. Right? So what I mean to tell you is, if you see the table or if you see the chart, we have discussed about different way of writing the given organic compound. Different way of writing the given organic compound. So that's where we have the line structure, which is also called as skeletal structure. Then we have the condensed structure, Lewis structure, dash structure, right? All these are the examples for different way to write the given organic compound. Then we have discussed about homologous series. Then we have discussed about the homologous series. So what do you mean by homologous series? So these are the hydrocarbons which differs from each other by one methylene group. So what do you mean by methylene group? CH2. That is nothing but a methylene group. So homologous series means what? These are the hydrocarbons which differs from each other by one methylene group. For example, we have propane and butane, and propane and butane. So which differs? Butane is having one extra methylene group compared to the propane, right? So that's where we have the homologous series. Okay? Now, when it comes to the functional groups, that's what we were talking about in the last class. With respect to the functional groups, anyway, I will remove these things and we are going to continue with the functional groups. So what are functional groups? So these are the part of a given organic compound. This will be the part of a given organic compound which will be having group of atoms, which includes group of atoms which are arranged in a particular manner. So those group of atoms, they are arranged in a particular manner. Now very important point here is they are going to decide the chemical property of a given organic compound. They are going to decide the chemical property of a given organic compound. All of you have understood? So that's where we have the functional groups. Now if you remember, in the last class we have discussed about COOH. Many students, observe it carefully, many students they will write the structure of carboxyl group. They will write like this. This is not acceptable. You have to show one line because carboxyl group will not be present alone. They will be present, they will be attached to a given organic compound. So therefore, you have to show this particular line which indicates that there is something before this carboxyl group, something is there. What is that something? It is the part of the organic compound, right? So therefore, we have the carboxylic acid as one of the important functional group. Okay. Now, carboxylic acid can also be represented as COOH. Carboxylic acid can also be represented as COOH. 1 minute. Okay. So that's where we have the different way we can represent the carboxylic acid. So which is a functional group. So carboxylic acid functional group. Okay. So why it is called as acid? Carboxylic acid. Why we call it as an acid? That is because it can easily dissociated into H plus or COO minus or COO minus, or we can also write it as COO minus. That's where we have the carboxylate. That's where we have the carboxylate. Now when I am telling oic acid, that is ic acid, that means H is attached to the oxygen. But when I am telling 8, when I am ending up with 8, that means H plus is not there, ionic form. All of you have understood? So that's where we have the carboxylic acid as one of the important functional. Yes, good morning, Dikshit. Good morning, everyone. Okay, na? So that's where we have the carboxylic acid. All of you have understood? Any doubts? No. Whenever Dikshit will be sending the message, it will be in bold letter, capital letters. So that's why I will be laughing. Okay? Fine. And earlier used to send 3 times. So therefore, I will be laughing while telling good morning. Okay? Nothing else. Okay, fine. Good morning, everyone. So Rakesh, please explain once. Okay, fine. So what I was telling here is we have a functional group which is called as carboxylic acid, which can be represented in 2 ways. This is also correct. This is also correct. Okay. Now, if I see this carboxylic acid, they are called as acid because they can release the H plus. They can release the H plus, and therefore they can be in non-ionic form or ionic form. So this is no charge, non-ionic form. So this is ionic form. So whenever it is non-dissociable, whenever carboxylic acid, they are intact, where H plus is not released, then it is called as carboxylic acid. Once the H plus is released, now it will be called as carboxylate, ATE, ending up with ATE. If you remember, yesterday we have discussed about one of the molecule. What is this? Common name is acetic acid. Right? This is acetic acid. Now, once H plus is released from acetic acid, now we can write it as acetate. Can you observe here, name of the molecule? I will call it as acetate, carboxylate, carboxylic acid, acetic acid. Acetate, carboxylate. Why? Because carboxyl group is dissociated. Carboxyl group is in dissociated form. Now whether I have reached to Rakesh? All of you have understood? So that's where we have got the explanation with regard to this particular functional group. Okay? Now important point here is we have a particular structure which is called as carbonyl group. Which is called as carbonyl group. And we have another structure which is called as hydroxyl group, which is called as hydroxyl group. Anyway, these things you are going to study in the next during reactions also. Fine. So that's where together we have the carboxylic acid as one of the functional group. Now please remember a given organic compound, if they are having carboxylic acid as that functional group or carboxylic acid is present in that structure, then the name of that molecule should be ending up with oic acid. Okay? Now I have CH3, CH2, COOH. Okay? Now we have to consider even this carbon. There is a carbon in carboxylic acid also. So therefore 1, 2, 3. So how many carbons are there? 3 carbons. So that means it should be propane derivative. It should be a propane derivative. If you recollect, when we discussed about the propane, even propane was having 3 carbon. 1, 2, 3. Right? So it is a propane derivative. So we will call it as propanoic acid. We will call it as propanoic acid. Okay? Because propane, it is derived from the propane, where E will be replaced by oic acid. Propanoic acid. Same way, I have benzene. I have the benzene. This is nothing but a benzene. Okay? So homocyclic ring structure, aromatic molecule, benzene. Now if I attach benzene with carboxylic group, benzene with a carboxyl group, then I should call it as benzenoic acid. I should call it as benzenoic acid. Okay? So that means carboxylic acid will act as a functional group where whenever carboxylic acids are there, name of the molecule should be ended up with oic acid. Any doubts? Try to understand these things properly. Even in second year it will come. 1 mark question for IUPAC nomenclature or writing the structure of the molecule. Definitely they will ask. Sir, I am not able to see, sir. Okay. For everyone same problem? Our board is clear? 1 minute. Now whether it is visible? I have reduced the brightness. I have reduced the light intensity. Sanjay, whether it is visible? Okay. So I think Sanjay, in that case, can you rejoin? Maybe network issue. Okay, fine. Okay. So if I stand far, I think it will become bright, dark. Whether you can see now, I think it's went. Okay. So that's where we have the molecule. Okay, done? So that's where we have the carboxylic acid as one of the functional group. Shall we move to the next one then? Another functional group, I will pick it up. Okay. So in a carboxylic acid, which and all it is there? So we should increase the resolution. That one, how to do, I don't know. I can increase the brightness, that's it. Okay? Or I will change the pen. Okay. Right? So next one is SO3H. SO3H. Next one is SO3H. So it's important to 1 mark. It's important with respect to IPAC nomenclature. 1 mark question it will be there. Either they will give the name of the molecule with IPAC name, then you have to write the structure, or they will give the structure molecule and you have to write the IPAC name. Okay? So that way they will ask the question, even for competitive exams. Okay? That's why we have the another functional group which is called as sulfonic acid. Another functional group which is called as sulfonic acid. Okay? Now, whenever this sulfonic acid is there, it is also called as acid because it can donate the H plus and it can become sulfonate. It can become sulfonate, just like we have discussed with respect to carboxylic acid, where we had carboxylic acid which can dissociate to form the carboxylate. Yeah, at the end we are going to discuss Ashish. Why I am not giving now? Because first we will try to understand these functional groups. Then we have some of the rules. So at the end, after all the explanation, we have to solve some of the questions related to IPAC name. Okay, Ashish? First try to understand about these functional groups. Fine? So when I am talking about sulfonic acid, why it is called as acid? Because there is a release of H plus. Okay? Now it can be dissociated as sulfonate. Don't get confused. We have SO4 minus 2, that is sulfate, which we will observe when sulfuric acid will be dissociated. Sulfate, SO4 minus 2. Here it is SO3 minus 1, sulfonate. SO3 minus 1, sulfonate. So that's what we have the functional group, another functional group. Okay? Now, if I have a molecule like benzene, if it is attached with the sulfonic acid, then I should call it as benzene sulfonic acid. Then I should call it as benzene sulfonic acid. Got my point? So what I need to tell you is, when I am talking about carboxylic acid, name of the molecule was ended up with oic acid. When a functional group is a sulfonic acid, name of the molecule should be ended up with sulfonic acid. Got my point? They are all very important functional group, especially carboxylic acid. It's very important functional group. All of you have understood? If propane, a 3-carbon hydrocarbon is attached with sulfonic acid, then it is called as propan sulfonic acid. It will be called as propan sulfonic acid. Okay? So that's what? CH3, CH2, CH2, SO3H. Then it is called as propan sulfonic acid. So what I mean to tell you is, name of the molecule should be ended up with sulfonic acid. Okay? Now if you observe, this functional group does not have carbon in its structure. Sulfonic acid does not have carbon in its structure. Fine? Any doubts in this? This is related to sulfonic acid. This is related to sulfonic acid. Any doubts in this regard? If you have any doubts, you can send the message. Then we have another functional group which is called as cyanide, or important point here is when CN is attached to any inorganic element, then it is called as cyanide. See, for example, when we have NaCN, we will call it as sodium cyanide. We will call it as a sodium cyanide. Okay? But when it is attached to the carbon, sir, in which element sulfonic acid is added? In which, what do you mean by Ashish? I am not getting the point. Any compound, organic compound, if it is added with sulfonic acid, now it should be called as, name of that molecule should be added with sulfonic acid. Okay? Got my point? Like benzene, sulfonic acid and all. Is there any limitation? Limitation with respect to what? Limitation with respect to what, Ashish? With respect to number of functional groups or number of carbon? There is no limitation. Any organic compound might be having sulfonic acid in its structure. But when more than one functional group is there, we have a different strategy. I will explain that one while we discuss about the IUPAC nomenclature. Now don't get confused. An organic compound might be having more than one functional group. Carboxylic acid might be there, sulfonic acid might be there, aldehyde might be there in the same molecule. Then we have a different strategy. Okay? So that one we will discuss. No need to worry. Fine? So when I am talking about this group, when it is attached to an inorganic element like sodium, then it is called as sodium cyanide. Then it is called as sodium cyanide. But when it is attached to an organic molecule, when it is attached to a carbon, then it is called as nitride. Then it is called as nitride. Then it is called as nitride. So therefore I will use this one as nitride functional group. I will use this one as nitride functional group. Got my point? All of you have understood? Now for example, I have CH3CN. I have CH3CN. How many carbons are there in this? 2 carbons are there, 1 and 2. Okay? So naturally, this molecule will be called as acetonitride. This molecule will be called as acetonitride. Same as that of the acetic acid, if you remember. CH3COOH, 1, 2. It will be called as acetic acid. Same way it is called as acetonitride. All of you have understood? Any doubts? Okay. So that's where we have another functional group, that is nitrile functional group. That is nitrile functional groups. Fine. Okay, Ashish, not only sodium, any inorganic element other than the carbon, they are called as inorganic. So any of those elements, if they are attached with cyanide, means CN group, then it is called as cyanide. Say for example, AgCN. It is called as silver cyanide. It is called as silver cyanide. Other than the carbon, to any other element, if CN group is attached, then it will be called as cyanide. But when it is attached to the carbon, now it is called as nitride. Whether I have reached you? Not only sodium, any other element other than the carbon. What I mean to tell here is CN group will be present in case of the inorganic molecule also, inorganic compounds also. So when they are present in inorganic molecules, they are called as cyanide. But when they are present in organic compound, they will be called as nitride. Okay, that's what. Fine. So that's what we have discussed about the cyanide functional group or nitrile functional group. Then we have another important one, carboxylic acid, and this one you will come across very often. Okay. So in the second PO, even Viva boss will be there based on the functional group. So this is called as aldehyde functional group. This is called as aldehyde functional groups. Now this can also be written as, or simply we can write it as like this, one and all same. All of them I am representing. Does not cyanide occur in natural form, sir? It is there. It's a poison, toxic molecule. It is toxic in nature. Okay, Rohan? Fine. Say for example, if terrorist, police have caught the terrorist, in film they will show na. So immediately they will eat something, and within few seconds they will die also. Okay, that much fast it will not happen, but that is called as cyanide. Cyanide is toxic in nature. Fine. So it is present in the nature. Okay na? So when I am talking about this one, this is called as aldehyde functional group. This is called as aldehyde functional group. Now, for example, I have CH3, CH3. What is this? This is nothing but ethane. This is nothing but ethane. Now, I will write another molecule, that is this. Now, we can call this molecule as ethanol. Ethanol. Observe it carefully. Ethanol. Same way, I have CH3, CH2, CH3. That is propane. That is propane. When I will write CH3, CH2, CHO, then I will call it as propanol. Propanol. All of you have understood? All of you have understood? Or we can call it as propanaldehyde, ethanaldehyde. Okay? Anything is fine, but normally we call it as ethanol, propanol. So what I mean to tell here is, when it comes to the carboxylic acid, the name of the molecule used to be ended up with oic acid. But when we are talking about aldehyde, molecule will be ended up with Al. Al. It's not OL. Al. It is ending up with Al. Al. All of you have understood? So this is another important functional group. Aldehyde functional group. If you observe it carefully, here also we have the carbonyl group. Here also we have the carbonyl group, but there is no OH, it is H. That's where the difference between carboxylic acid and aldehyde. They cannot release this hydrogen as H+. In carboxylic acid, why it was released as H+? Because it was attached to an electronegative element oxygen, which used to take the electron and used to be dissociated as O minus H+. But here carbon is not electronegative as that of oxygen. So therefore aldehyde we will not consider it as an acid because it's not going to release the H+. Fine. So that's where we have the propanol, ethanol, benzaldehyde. So all these molecules, their name will be ended with either aldehyde or Al. Okay. So when we are dealing with linear hydrocarbon molecules, aliphatic compounds and all, then we will call it as Al, propanol, ethanol. Fine. Okay. And we have to consider the carbon of aldehyde also. When you are naming, we should consider the carbon of aldehyde also. CH3, CHO, that's for it is a 2 carbon. So ethane derivative. Fine? Okay. So we will come to another important one, that is ketone. This functional group is called as ketone. When we are talking about CO, when we are talking about CO, sir, what is aldehydes called when? That's what. It can be ended up with Al, propanol, or we can call it as propanaldehyde. Anything is fine. So propanol or propanaldehyde. Ashish. Yes, Ashish. Aldehyde will not be attached to inorganic molecules. Only cyanide is the example. We don't have AgCHO. We don't have AgCHO. No. Aldehyde group is found only with respect to organic compounds, not with respect to inorganic compounds. Exceptional case is cyanide, which is the only thing which can observe in inorganic compounds also. But all the other functional group, they are specific to the organic compounds. Fine? Whether I have reached you? Ashish? Okay, done. So that's what. This is called as ketone. Now many students, they will get confused that, sir, in aldehyde also we have this particular structure. In carboxylic acid also we have this particular structure. And here also we have the same structure. But here we are calling it as ketone. In this case we are calling it as ketone. But in this case we are calling it as carbonyl groups. We are calling it as carbonyl groups. What is the reason? Why we are having such a discrepancy? Why everywhere we will call it as a carbonyl group? Why ketone at one time and why carbonyl group at another time? Now, I will make it very clear. When this carbonyl group, CO is the part of the structure of any other functional group, then they will be called as carbonyl group. When this is the only one where it is acting as a functional group, then we will call it as ketone group. Whether I have reached you? Got my point? When CO group will act as a functional group, when it's going to decide the chemical property of that particular compound, then we will consider that one as a functional group. Now we will call it as a ketone functional group. Okay? But when they are part of any other functional group, where they are not going to play the chemical properties of that compound, that chemical property will be decided by the whole structure, not only by this one. So during that time it will be considered as carbonyl group. All of you have understood? Fine? Okay. So I have a compound CH3, CO, CH3. Okay, this is a compound. One thing you should remember that carbonyl group cannot be present on the terminal. On the terminal, carbonyl group cannot be present. For example, CH3, CH2, CO. This cannot be done. We don't have any element, any compound like this, because carbon is having only 3 here. Sir, give one hydrogen, sir. Okay, I will add one hydrogen. Now it is no more ketone group, it is aldehyde group now. Okay? So what I mean to tell you is, unlike other functional group, listen to me carefully. Unlike other functional group, when we are talking about the ketones, they are not going to present at the end of any of the organic compound. They should be present in between. Got my point? So this molecule, 3 carbon is there, right? So therefore it is a propane derivative. We will call it as propanone. We will call it as propanone. Or common name can be acetone. Common name can be acetone. If you recollect, why we are calling it as acetone? Because 2 carbon with 1 ketone group. Therefore acetone. Why we are calling it as propanone? Because it is having total 3 carbon. Don't get confused. So when it comes to acetic acid, it was a 2 carbon compound. When it comes to acetaldehyde, right, it was a 2 carbon compound. Then why you are mentioning acetone here? It is 3 carbon. Acetone we will mention by considering these two as the main carbon to which ketones are present. It is the common name. But IUPAC name is propanone. 1, 2, 3. Propanone. All of you have understood? Acetone or propanone. So don't get confused. So when I am talking about acetic acid, CH3COOH, acetaldehyde, CH3CHO. So in this case, ethanol ethanoic acid. Why we are calling this one as acetone then? 1, 2, 3. 3 carbons are there. But here 1, 2, only 2 carbon. The reason is very simple. We will consider this one as a functional group. We will not going to consider this carbon. We will consider only these two. So therefore we will call common name as acetone. We can call it as acetone. We don't have a ketone with 2 carbons. It's not possible. Because we cannot have a compound CH3CO does not exist. CH3CO does not exist. Ketones will have only minimum carbon should be 3. For ketones, minimum carbon should be 3. Okay? Yes, Rohan. All of you have understood? Not oxygen. Oxygen is present here. Carbon is only there, but we will consider this one as a one particular group which is attached to CH3CH3. Therefore, we will call it as acetone. But acetone is a common name. Scientific name or IUPAC name is propanone. It is propanone because it is a 3 carbon. 1, 2, 3. You name 1, 2, 3 here or 1, 2, 3 here. One and all same. But we don't have a ketone with 2 carbon. It's not there. All of you have understood? Any doubts? That means name of the molecule, ketone, should be ended up with O, propanone, acetone. That means name of the molecule should be ended up with O. Don't write 1. It's not 1. O. There is one line that indicates that something is there before this one. So therefore it is O. Name of the ketone should be ended up with O. Propane will become propanone. All of you got my point? Okay, any doubts? Same way, we have another important functional group, carboxylic acid, aldehyde, ketones, and this one. They are all bit important. Very often you will come across. So that is OH. That is OH. Now, as a molecule, we used to call this one as hydroxyl group. We used to call this one as hydroxyl group. When we are not considering this one as a functional group, we will call it as hydroxyl group. Otherwise, when it is acting as a functional group, then we will call it as alcohol functional group. Then we will call it as alcohol functional groups. All of you have understood? So that's where we have the hydroxyl group when we consider only as OH. But when we consider or when it is behaving as the functional group, then that will be considered as alcohol functional group. A simple example is, we have a molecule that is glucose. We have a molecule called as glucose. Now if you observe this particular organic compound, which is a carbohydrate, anyway in second year we are going to discuss in detail. In this case we have so many OH group. All of you can see we have so many OH group. But that will not be considered as a functional group in glucose. That will not be considered as a functional group. It will be considered as aldehyde as its functional group, which is going to decide the property of this particular molecule. So during that time we will call this one as hydroxyl group. We will call this one as a hydroxyl group. That's what I mean to tell. Same as that of the ketones. When carbonyl group, when they are acting as a functional group, they are called as ketones. But otherwise simply they will be called as carbonyl group. when they are not having the functional group property. Got my point? So that's why we have the OH as alcohol functional group. One of the important example is, what is that? New Year party, right? So that means when I am talking about CH3, this is ethane. This is ethane. Now we have alcohol which will be attached to it, that is OH. This will become ethanol. This will become ethanol. Got my point? So OH group can be either this terminal or this terminal. But OH functional group does not have carbon in its structure. Okay, does not have carbon in its structure. So 1, 2, only 2 carbon. That's why E will be replaced by O. When we have the alcohol functional group, E will be replaced by OL. All of you have understood? Got my point? Okay? And OH group can be present anywhere, on the terminal or in the mid of the carbon, middle of the carbon, anything. For example, I have CH3, CH2, CH2, OH. So this is propanol. This is nothing but propanol because it's a propane derivative, 3 carbon, 1, 2, 3. Now, alcohol group can also be present in the mid carbon. Can also be present in the mid carbon. Now, this can be called as isopropanol, where iso talks about it is present in the middle of the carbon. Isopropanol. They have the similar molecular formula. Propanol and isopropanol, they have the similar molecular formula. Therefore, iso. Iso means same. Same as that of the propanol. That means isopropanol means isomer of the propanol. Why we call it as isomer of the propanol? Because both of them they are having same molecular formula, not chemical property. They are having same molecular formula. For example, C3, 3 carbon. How many hydrogens are there? 2, 2, 4, 4, 3, 7 and 8. H8O. Right? Molecular formula. So here also it will be C3H8O only. That means when I am talking about propanol or isopropanol, they are having same molecular formula. So therefore that molecule will be called as isopropanol because it is an isomer of propanol. All of you have understood? So that's why we have the molecule with alcohol group. Alcohol functional group can be present on the terminal carbon or it can be present in the mid of the carbon. Anything is fine. Now if I want to write the IUPAC name, then I should call it as propan 2-ol because at the second carbon, 1, 2, 3, at second carbon alcohol is there. Propan 2-ol, name of the isopropanol. Isopropanol is the common name. If I want to go with IUPAC name, then propan 2-ol. Here we can mention it as propan 1-ol or it's understood when I am writing propanol, where alcohol is attached to first carbon. Got my point? So that's where we have the alcohol functional groups. That's where we have the alcohol functional groups. Any doubt? Okay? Any doubts up to here? Then we have another functional group which is called as amino functional group. Amino functional group. This is called as amino functional group. Okay, amino group. Since it is derived from ammonia. Since it is derived from the ammonia, that's why we have the amino functional group. Okay. Now, name of the molecule always ended up with amine. Name of the molecule always ended up with amine, ethanamine. So, for example, CH3, CH3. It is nothing but ethane. But when it is attached to amino group, when it is attached to amino group, now I will call it as ethanamine. I will call it as ethanamine. That is because we have the amine functional group which is attached. E will be replaced, ethane, E will be replaced by amine, ethanamine. Got my point? So another important functional group. Another important functional group. All of you have understood? Any doubts? Okay, so these are some of the functional groups which will be very important with respect to your organic chemistry. Okay, along with that, even we will consider double bond. We will consider double bond as the functional group. Even we will consider triple bond also as a functional group, because they are also reactive part of the molecules. They are also a reactive part of the molecules. Any element or organic compound having double bond, their name will be ended up with E. Their name will be ended up with E. Any molecule which are having triple bond, their name will be ended up with YN. YN. Okay? Ethyne. Like that it will be ended up with. Okay, now that's where we have ENE, YNE. All of you have understood? So even double bond and triple bonds, they will be considered as functional groups, because even they are the reactive part of the given organic compound. So therefore they are also considered as a functional groups. Or if you got my point, any doubts? Any doubts? Right? Now just before 10 minutes back, Ashish was having a doubt. Sir, any limitation with respect to functional groups? Then I told, when we have an organic compound, when more than one functional group is there, then we have a different strategy, I told. Okay, we cannot give all the name. A molecule is having CHO, OH. Then we cannot name the molecule as LOL. We cannot do that one. Any one we have to select. Any one we have to give the preference. So in that case, when I am talking about functional groups, this is important to make the usage with respect to IUPAC nomenclature. Preference with respect to functional groups. With respect to functional groups. And I am talking about those, there was some network issue, all of you are here, right? So that's where we have the preference with respect to functional group. Please remember, I am talking when based on when more than one functional group is there. When more than one functional groups will be there. During that time this is applicable. During that time this preference list is applicable. Okay. Now preference with respect to functional group, where molecule name will be ended up with based on these functional groups. They are called as suffix. They are called as suffix. So what do you mean by suffix? Like a surname. Like a surname. For example, now Raghavendra surname is Raghavendra Hegde Katte. So Hegde Katte is my surname. Okay. So whenever these functional groups will be there, the molecule name will be ended up with based on these functional groups. Therefore they are called as suffix. They are called as suffix. So now the preference, very important preference or very important functional group is carboxyl functional group. Okay. So any other functional group might be there. If there is a presence of carboxyl group, then the name of the molecule should be ended up with carboxylic acid functional group. Got my point? Say for example, I have a molecule COOH, then OH, which is the precursor for the synthesis of aspirin. one of the important drug, right? Now this molecule we have OH also, carboxyl group also. Now if I take out carboxyl group, this molecule is actually phenol. Alcohol group is there, phenol, OL. But when carboxylic acid is there, now this molecule will be called as benzoic acid. We will call it as 2-hydroxy. We will call it as 2-hydroxy benzoic acid. Can you see the difference? Right? So that means now this will not be considered as a functional group. This is called as 2-hydroxy. Okay? And this will be considered as a functional group. Therefore, name of the molecule will be ended up with oic acid. 2-hydroxybenzoic acid. Okay? Now, if I have only OH group, no carboxylic acid, only OH group is there. Now it is called as phenol, OL. That means alcohol, phenol. All of you have understood? Any doubts? That's what this preference list talks about. Don't get confused. When we have more than one functional group, which functional group should be given importance? That's what I mean to tell. Okay? So when OH is alone, molecule name is ended up with OL. That's what all this functional group, which I am going to mention now, all of them, they will be used as a suffix. They will be used as a suffix. Name of the molecule will be ended up based on those functional groups. Okay? If you have any doubts, you should ask. So that's where first preference will be given to carboxylic acid. Then comes with respect to sulfonic acid. Then comes the preference with respect to sulfonic acid. Only common one I will take. Then the preference will be given to aldehyde group. Then comes the ketones. Then comes the ketones. You can make the list. It's important. Then comes the OH. Then comes the OH. Okay? Then we have the amine functional group. Then we have the amine functional group. Okay? Okay. Before here, even we can include nitrile group also. Nitrile group also we can include. Okay? No place. I will rewrite it. This part. Preference will be given to carboxylic acid. Then comes the sulfonic acid. Then comes the nitrile group. Then aldehyde group. Like that, the list will go on. And lastly, we have the double bond. Double bond. Then we have the triple bond. Okay? All of you got my point? So if carboxyl group is there, any other functional group might be there. But the name of the molecule should be ended with oic acid. If carboxyl group is not there, but sulfonic acid is there, but any other functional group, name of the molecule should be ended with sulfonic acid. Sulfonic acid is also not there. We have the nitrile group and any other functional group. The name of the molecule should be ended with nitrile. So that's what preference talks about. And every time, whenever I am telling, name of the molecule should be ended up with. That means surname. Name of the molecule should be ended up with. That's what suffix. This is the preference list with respect to functional group, which will be always used as a suffix. Any doubts in this? Any doubts? This is important with respect to your IUPAC nomenclature. If you don't have any doubts, shall I move to the next one? Okay? Right. When I am talking about these groups, along with the suffix, as some of the functional groups, they will be used as suffix. Name of the molecule will be ended up with those functional group name. So therefore they are called as suffix. but at the same time we have some of the substituents. We have some of the substituents which will be always used as a prefix. Which will be always used as a prefix. See, for example, I have Cl. Okay? So chlorine is a substituent now. Now property of benzene will be decided by the chlorine now. Now it can be used as a functional group. But whenever these halogens are attached, they will not be considered as a suffix. Name of the molecule will not be ended up with benzene chlorine. We will not call it as a benzene chlorine. We will call it as chlorobenzene. We will call it as chlorobenzene. That is the correct one. But I cannot call it as benzene chlorine. This is wrong. So that means although here in this case chlorine can act as a functional group which can decide the property of the organic compound, but here the name will be used as a prefix. Names will be used as a prefix. For example, Raghavendra Hegdekatte. In this, Raghavendra is a prefix. Okay? So that's what. Some of the functional groups, they will be used as a prefix. So chlorobenzene, not as benzene chlorine. All of you have understood? Same way, we have the, I am taking simple examples. So same way we have CH3, methyl group. CH3, methyl group which is attached. Now methyl benzene, common name is toluene, that is different. But we can call it as methyl benzene. Methyl benzene. Okay, what I mean to tell you is, like ethyl, methyl, we have CH3, then we have CH2, CH3, then we have CH2, CH2, CH3. Observe it carefully. This is called as methyl. This is called as ethyl. This is called as propyl. So what I mean to tell here is, all these molecules now acting as a substituent. So therefore, ethane will become, methane will become methyl, ethane will become ethyl, propane will become propyl. So therefore, in general, we will call it as alkyl derivatives. We will call it as alkyl derivatives. Try to understand all these things properly. It will be easy for you to name the molecule, IUPAC naming. Okay? Alkyl derivative in general. Even alkyl derivative will be used as a prefix. Alkyl derivative will be used as a prefix. All of you have understood? Any doubts? So what I mean to tell here is, some of the groups, they will be considered as suffix. They are very important one. Name of the molecule, they will be ended with that particular functional group. But at the same time, there are some of the functional groups which will be used as a prefix, where name of the molecule will be started with those particular substituent. Okay? Anyway, I will stop here. Any doubts? So try to practice whatever I have taught, practice in the sense, try to read whatever I have taught. Okay? Any doubts, let me know. But while coming tomorrow, you should be having this particular information. You should practice. Then it will be easy for you to go for IUPAC nomenclature. Okay? Any doubts in today's class? I can see very less attendance. It's fluctuating, I don't know. But please try to understand and come for the live class where you can have the discussion. Okay, na? So in that case, shall I stop then? Okay? Thank you. Thank you very much. Take care. So tomorrow we will continue.